If it's worthwhile having some of these syntactic forms as sugar, then one way you can implement that is by taking an existing language and replacing the parse function. Can still reuse the interpreter, can still reuse the type checker if there is one. And we see this strategy. Here I've got a core interpreter, core.racket. It's very much like lambda.racket. I've just thrown back out let forms and additive zero forms to match the gram on the slides. And as usual, we have the parser, and then we have the interpreter and various test cases, including the lookup for environments. Now we can reuse this core interpreter, but add some syntactic sugar, like the case form, by writing a new parser. So here I have parse2 that looks very much like parse. It does all of the same things, but in addition it handles let in the way that we've seen before. We can just reparse the form after rearranging the pieces. And we take the symbol here, which is first a vs, and put it as a lambda argument. The right-hand side of the let becomes the argument to the lambda, and then the body of the let here becomes the body of the lambda. And then we can just reparse that application lambda combination. Similarly, we can implement case by, as long as we have at least one clause, then we make up some temporary variable, bind it to the value of this expression, and then subtract this number negated. If we get 0, then we go to right-hand side, which is this expression. Otherwise, for the else case, we continue with another case, just leaving off this first clause so that we have this clause and the ones after it. And then a case. Then we have an extra parser clause for when we have case with just else. Then we can just evaluate this expression followed by this expression. That's what we do here. So this all works. We get the extended language. If we jump down to the end here, you see that we can parse an expression that uses case in it, and when we run the test it gets the right answer. We also have another test case here just to check on how case parses in some simple forms and some more elaborate forms. But then we also have to check all the other forms because we've rewritten the parser. So we have to duplicate not only the parsing work that we had before, but all of the test work that we had before. Instead of duplicating all of these test cases and all of the parsing that the core parser already does, we would like to reuse this core parser. The problem is that as soon as we call parse and it needs to parse sub-expressions, then it just calls itself again. And so we never get to see any extensions, even though we can handle like a let or a case on the outside. It's when a let or a case is under a plus that we wouldn't get a chance to handle that. To be able to reuse this parser, then, we need a hook that lets the extension interpose on handlings of S expressions. So we'll have a parse star that takes an S expression and an expand function, which that's our hook there, that the expand function gets first chance at every S expression. So expand can choose to rewrite the S expression, in which case it returns some rewritten S expression, and parse star continues by parsing that rewritten S expression. Or expand chooses not to handle it, it returns none, and parse star will work just the way that parse used to, except where everywhere that parse recurs, it's going to recurse with parse star instead of parse. And then core can also provide a regular parse function that just calls parse star with an expand that doesn't handle any other expressions. On the other hand, now in our try and let extension, we can write a parse2 that mostly just reuses the old parse, or parse star now, providing an expander that handles let and case. So if an S expression matches a let pattern or a case pattern, then our expander here will handle that and return some expanded S expression. Otherwise, it'll just return none. And if we look at the code, that's core extensible, which looks the same as before, but now with parse star instead of parse. Parse star recurs with parse star and gives the expander the first chance there to expand the expression. And we have a parse that just uses parse star with empty, and then the extension of this language using that extensible core reuses parse star, just passing in an expander for let and case. So this expander, when it sees something that matches the let or one of the case patterns, then it provides a rewritten S expression. Otherwise it does nothing and reuses the old expander, old parser. And now we just have to test the new parts, the let and case, and so on.